given a thin convex lens of glass, refractive index mu, and each side having radius of curvature r. One side is polished for complete reflection. At what distance from the lens an object be placed on the optic axis so that the image gets formed on the object itself? So, see the problem. It says here it is a convex lens. For a convex lens of radius of curvature r, and one side is polished. Let's say this side is polished. So it acts as a mirror. At what distance? So an object is put on the optic axis, let's say here. So at what distance the object is placed so that the image formed on the object itself. So the image, if the image is here, object is here, then the image is also here. Now see the combination of lens and mirror. So this basically acts as a lens and mirror system. So first the ray goes to this lens, convex lens, then it reflects from this mirror. So this lens M, then it goes to the mirror and reflects, and again it comes back to the lens. So the ray goes through lens, reflects from mirror, and again comes here and form the image. So the reflection, so it is basically two lenses and one mirror. Now we know that the power, let's say power of lens is PL and power of mirror is PM. So the total power P equivalent is equal to P lens, that is P lens plus P mirror plus P lens, that is twice PL plus PM, that is twice PL plus PF mirror. So this is the P equivalent. So equivalent power is, we know the equivalent power is equal to the total power individually. So twice PL plus PM. So that's why it is taken twice PL, because the ray goes through the lens, then reflects from the mirror, and then again comes back to the, and then again goes through the lens. That's why it is PL plus PM plus PL. Now we know that for a lens PL, we first calculate the focal length. Now if we take the focal length, P is equal to 1 by F, that is 1 by F equivalent is equal to 2 divided by F equivalent. Now here is a trick, because the ray goes to this direction and reflects back. So this system acts as a mirror. So this total system acts as a mirror, and we know that for a mirror the power is P is equal to minus 1 by F. So P equivalent will be minus 1 by F equivalent, and for a lens PL is equal to 1 by F lens, and again for the mirror PM it is minus 1 by F mirror. So minus F 1 by F is equal to 2 by FL minus 1 by FM. So now calculate the FL and FM. So for the lens L, we know that 1 by FL is equal to mu minus 1, that is mu lens divided by mu surroundings. So mu, this is, and the surrounding is air, so this is basically mu minus 1, 1 by R1, 1 by R1 minus 1 by R2. So this is mu minus 1. Now R1, so the light goes in this direction, and the radius of curvature of the first surface is, if we complete this sphere, then radius will be, it is, so the direction is same as that of the incident line. So R1 is positive, that is 1 by R. Now if we find the radius of curvature of the second surface R2, then the R2 is in this direction, so it is opposite to the incident line, so we have to take a negative sign from the sign convention. So this becomes minus of minus 1 by r, that is plus 1 by r, because both the surfaces have the same radius of curvature r, it is given in the question. So this becomes twice mu minus 1 divided by r. So 1 by FL is equal to twice mu minus 1 by r. So, and the focal length of the mirror. So for the mirror of radius of curvature r, so the mirror of radius of curvature r is focal length Fm is equal to r by 2, and it is negative, so minus, so let's say it is plus r by 2, f is equal to r by 2. So focal length, the relation between focal length and radius of curvature is f equal to r by 2, and as the radius of curvature is in this direction, so we have to take negative sign, so fm also becomes negative, that is minus r by 2. Now put the values of fm and fl, that is minus 1 by f equivalent is equal to 2 by fl, so 2 divided by fl is now 1 by f, so 1 by f is equal to 2 mu minus r, so this becomes 2 into 2, that is 4 mu minus 1 divided by r, and this negative, and here fm has a also negative minus r by 2, it becomes positive, so it is become 1 by f is equal to 2 by r, or minus 1 by f equivalent is equal to, take r as LCM, then it becomes 4 mu minus 4 plus 2, that is 4 mu minus 2 divided by r, or minus 1 by f equivalent is equal to 4, take 2 as common, that is 2 mu minus 1 divided by r. Now we get the equivalent focal length, so we get the equivalent focal length of the lens, that is f equivalent 1 by f equivalent is equal to minus twice 2 mu minus 1 divided by r. Now the system, the total system, that is the lens and mirror system, acts as a mirror, and we have to find the location for which the object distance and image distance are same. If r equivalent is the radius of curvature of this equivalent lens mirror system, then the object must be put at the center of curvature of this equivalent system, then only the image will form at that center of curvature. See, so between f equivalent is equal to r equivalent divided by 2, so the object should be put at r equivalent, or r equivalent is equal to twice f equivalent, so we have to find r equivalent, that is twice f equivalent. Now if we multiply this, that is twice f equivalent is equal to minus r divided by 2 mu minus 1, so this is r equivalent, so twice f is equal to r for a mirror, this is becomes minus r divided by 2 mu minus 1, so we find the distance, that is r divided by 2 mu minus 1, here it is negative sign, so the distance is negative, but we check the answer, that is, so the answer is r divided by 2 mu minus 1, so in the question it only wants the distance only, so find at what distance from the lens, so they ask the distance only, so the sign is not there, so option 4 is the correct answer, r divided by 2 mu minus 1. Thanks for watching. Please like this video, subscribe my channel and share.